Let us see the second phase of the compiler called as syntax analysis. As we all know, all high level programming language has its own syntax and a precise rule to define the variables, statements, functions made up of expressions and so on. The syntax of these programming language construct can be specified by a context-free grammar or a BNF notation. But the grammar offer a significant benefit for both the language designer and the compiler writer. So here we are going to make use of the grammar to construct the parse tree for a given input string. The main role of the syntax analyzer in the compilation process is to construct a parse tree for a given statement and check for the syntax errors. If the parse tree is not constructed successfully, then it will raise the errors, and those errors are called as a syntax errors. Sometime it will do the automatic error recovery also. The compiler mainly use two types of parsing methods. Top-down parsing and a bottom-up parsing. The top-down parsing is done by a top-down parser and bottom-up parsing is done by a bottom-up parser. As the name itself indicate, the top-down parser, it will construct the parse tree from root to the leaf nodes, whereas the bottom-up parser, it will start constructing the parse tree from leaf and it will move up towards the root node. The top-down parser is again divided into two methods: top-down parsing with backtracking, top-down parsing without backtracking. In top-down parsing with backtracking, we are going to select one option to parse the given input string, and at the end we come to know that this option will not successfully parse the given input string. So we backtrack and we'll check the other alternatives. In a TDP without backtracking, this is deterministic in nature. Whatever the option we selected, that will parse a given input string successfully. And the example for this method are the recursive descent parser and the non-recursive descent parser. Let us see the second type of a parser, that is bottom-up parser. The bottom-up parser is divided into two types: operator precedence parser and a LR parser. The LR parser is again divided into LR0, SLR, LALR and CLR. You are going to study all these parsers in a coming classes. All these parsers work on a unambiguous grammar except the operator precedence parser. The operator precedence parser also work on a ambiguous grammar. So you already know what is the ambiguous grammar and the unambiguous grammar. We will see these topic in next videos. So let us take one example and try to construct a parse tree for both the methods. Here I had taken one grammar, that is E produces E plus E, E into E, bracket E and ID. So E can be substituted by any one of these option. Based on the input string, you are going to choose the option for the, you are going to select the option for the grammar symbol E. And the input given here is ID plus ID into ID. Let us check the construction of the top-down parse tree. As I said, the top-down parse tree start the construction of the tree from the root node. Here the root node will be the grammar symbol itself, grammar start symbol itself. So what is the grammar start symbol here? It is the E. So that will be the root node here. So what is the first operator in the given input string? That is plus. So I should substitute E in such a way that I will get that operator. So which option I should select here? That is E plus E. So E can be substituted as E plus E. Then what is the first input string? That is ID. So how I get this ID? I can get this ID by substituting E as a ID. So I substituted E as a ID. So what I got here? ID plus E. So I can substitute this E as a ID. But if I substitute, what happened? The input string, accepted input string is ID plus ID. But here the given is ID plus ID into ID. So I will check the next operator. What is the next operator here? Into. So I will substitute a E in such a way that I will get that operator. So which option I should select for this? That is E produces E into E. So I substituted this E as E into E, and for the second V I will substitute ID, and this third V I will substitute ID. Check the leaf node of this parse tree. So here leaf nodes are ID plus ID into ID. Let us check the construction of a bottom-up parse tree. So as I said, the bottom-up parse tree will be constructed from the leaf and it will move up towards the root. The top-down parser, it will support the leftmost derivation, whereas bottom-up parser, it will support the rightmost derivation in reverse. So here we are going to reduce the I with a grammar symbol, ID with a grammar symbol. So we are going to check the right part of the grammar, and this right part of the grammar options are substituted with the grammar symbol. So first input string is ID. So ID can be reduced with the grammar symbol E because E produces ID. So first I will reduce this ID to E. So what is the next input symbol here? Plus. Any option is there to reduce this E plus? No. So what I will do next? I will take a next input symbol and I try to reduce this. What is the next input symbol here? ID. So this ID can be reduced with what? E. So I will reduce this ID with the E. After reducing this ID with the E, what I get? E plus E. So I can reduce this E plus E with the E. So I had reduced this E plus E with the E. So what is the next input symbol to accept? That is star. So any grammar symbol produce this E star? No. So I can't reduce this. So I will read the next input symbol. What is the next input symbol here? ID. So ID can be reduced with what? The grammar symbol E. So I will reduce this ID with the E. So what is the input string to accept here? E into E. So check out that E into E can be reduced with the E. So E into E can be reduced with the E. So here I reached the root node of the tree. I started with the grammar. I started with the input string and I moved towards the root node. The main problem with the top-down parser is what to use, means which production is used to parse the given input string, and the main problem with the bottom-up parser is when to reduce. So which symbol is reduced, the decision on that will be very difficult. So this is about these two types of parsing methods. Let us see the ambiguous and unambiguous grammar. As I said, all these parsers will work on an unambiguous grammar. Next, see what you mean by ambiguous grammar and unambiguous grammar. The ambiguous grammar is a grammar which has more than one parse tree for a given input string. Means the grammar remains same, the input remains same, but you will get the two different parse tree for a. Let us take an example and see the ambiguous and unambiguous grammar. So as I said, in an unambiguous grammar, the grammar remains same, the input string remains same, but you will get what? Two different parse tree. Let us check with the example. So here I had taken the grammar E produces E plus E into E, bracket E, ID, and the input string is ID plus ID into ID. So here I had applied a LMD twice, leftmost derivation twice, to parse the given input string. The first option that I selected is, first I replaced this E by E plus E. Then I substituted ID for first E. What I get here? ID plus E. Then I will substitute the next non-terminal E with the E into E. Then the first leftmost E is substituted as ID. Then the last E is substituted as another ID. So what I get at the end? ID plus ID into ID. Let us check the second LMD method, leftmost derivation. Here I started with the grammar symbol E. The option selected for a substitution of E is E into E. So here E is substituted as E into E. Then the first E is substituted as E plus E, because the first operator in the given input string is plus. To get that plus, I will substitute this first non-terminal E with the E plus E. Then I go on substitute ID for these E's, and this is a parse tree for a input string ID plus ID into ID. Check out the length of the parse tree and the nodes and the leaf nodes of the parse tree. So based on that, I can say, using the same grammar, using the same input for a given grammar, I had come with a two different parse tree. So based on this, I can say this grammar is ambiguous grammar. So the next question is, what type of ambiguity it has? So there are two types of ambiguity in the grammar. One is a leftmost factoring and another one is a left recursion. The left recursion is nothing but the left side of the grammar symbol occurred as a first part of the grammar production. So let us see this in the next class. Thank you.